Remember.
First times the derivative of the second times the second
Alright,
times the derivative
so
of
the first times the derivative of the second, so I'm going to have x times derivative sine cosine of x plus derivative of the first times the second. So derivative of x is 1 times sine of x. Okay, so if I integrate both sides, so I'm going to take the integral of x sine of x prime equal to, and remember, whenever we're doing antiderivatives, we have the sum and difference rule just like we would whenever we're differentiating. So I can break this up. So I'll have the integral of x cosine of x plus the integral of sine of x dx. Alright, so the antiderivative of the derivative of something is what? Well, itself. Okay, so this is x sine of x plus some constant is equal to the integral of x cosine of x dx plus the antiderivative of sine of x. Close. No, what you said, the antiderivative of sine of x is negative cosine of x. So this is actually minus cosine of x. That's some constant. Alright, so if I just resolve this for our original antiderivative, which is this right here, so I'm going to add cosine of x to both sides, and I'm going to subtract off my other constant. So it's going to give me x sine of x plus my original constant plus cosine of x minus the other constant is equal to my original integral. Okay. From here to here? Okay. So this was the original antiderivative. That's what we were originally trying to integrate. So I just went ahead and solved for it.
Oh, okay.
So I added cosine of x to both sides, and I subtracted off my constant on both sides. Does that make sense? A little bit? Alright. So now I have the integral x cosine of x dx is equal to x sine of x plus cosine of x. Now, I have one constant minus another constant, which is still just a constant, right? That is just a real number, so I'm just going to add some random constant in here. All right, now this is the formula that we have for integration by parts. Does anybody have any questions? This is how it was actually supposed to be done in the notes. Okay? All right, so now looking at the actual formula for integration by parts, says that if we have the integral of some function times the derivative of another function, that's equal to the two functions multiplied together minus the integral of the derivative of the first times the second. Which, if you look at our actual answer that we got, it is. Because if we let cosine be our g prime of x, and x be our f of x, then we can just follow the rule. F of x is x. What's the derivative of, oh, did I do that wrong? No. Oh, yes, no, I didn't do that wrong. Okay. All right. Sorry, one more time. So I have my f of x times the antiderivative of my g of x, my g prime of x, which the antiderivative of cosine is just sine. So the derivative of sine is cosine, right? Everybody see that? Did I just make a mess out of that? I did make a mess out of that. Alright, here's my f of x. And this is my g prime of x. Okay, so meaning I've already taken, quote unquote, the derivative of a function and I got cosine of x. What do I take the derivative of to get cosine? Sine. Okay, so our formula reads that if we take our first function times the original g of x, so you just told me if I take the derivative of sine, I get cosine. So this is g prime of x. If I take its antiderivative, which is sine of x, minus the derivative of the first function, so the derivative of x is 1, times my g of x, I love it. Which is just 1, minus my original function. Alright, so my f prime of x was just x, the derivative of it is 1, right? So I have right here, this is the integral of 1 times my original function, which was sine of x. What was the antiderivative of sine of x? What's the antiderivative of sine of x? What do I take the derivative of to get sine of x? Negative cosine of x. Negative cosine of x. So negative times negative cosine of x gives me my positive cosine of x. Okay, I know that's kind of a long drawn out way, but it is really important that you do relate the two together. Integration by parts really is just the reverse of the product rule that we have from taking derivatives. Right? Okay, so all that being said, let's look at actually using the formula and breaking it down. So we have the integral of x cosine of x dx. I'm sorry. Okay, so I have the integral of x cosine of x dx. So we do need to use integration by parts. So I'm going to pick one thing that helps me a lot. It's not going to happen in every single integral that you do by parts, but the one that I always, your f of x is the one you're going to have to take the derivative of. So what I always start with, sometimes it's trial and error, the one that I always start with to be my f of x that I'm going to have to take the derivative of is the one that's going to eventually disappear after I take the derivative of it so many times. Because what's the derivative of x? 1. So it's pretty much going to disappear, quote unquote, and so I'm not going to have to worry about it too much for the rest of my integration, right? And same thing if you have x squared. What's the derivative of x squared? 2x. What's the derivative of 2x? 2. So you might have to do it twice, but it's eventually going to disappear, right? Okay. So I'm going to let my f of x equal x, and then my f prime of x is 1 dx. Right? Does that make sense so far? Alright. So I'm going to let cosine of x be my g prime of x. And we already said that the antiderivative of that, what I take the derivative of to get cosine, is sine. Alright, so now it's just a matter of plugging things back in to our formula. So I'm going to have my f of x times g of x. So f of x times my g of x, so I get x sine of x, minus the integral of the derivative of my f of x, which is just 1 dx, times my g of x. So I have 1 times sine with me about 4 times now. Antiderivative of sine of x is negative cosine of x. So I have minus negative cosine of x plus some constant. So just simplifying a little bit, x sine of x plus cosine of x plus a constant. Which is the same thing we got from the long drawn out. It's the same exact thing. Okay? This one's more of starting with our product rule that we have from derivatives, taking the integral of both sides, and then showing you that they are the same. It's just the reverse of each other. Does that make sense? Or it's derived from the product rule.
So you just use the equation dot.
Right. This one, I actually just used the formula that we had, which is what I got over here when we actually derived it. This one was just using the formula without deriving it first. Okay? Yeah.
How do you know to put the g prime of x to be cosine of x instead of g?
Instead of what?
G.
Because we have f of x and we have g prime of x. That's what's going to be made up in our integral. So, like I said, sometimes it is trial and error, but whenever I do it, what I'm looking for, I know whatever I pick to be f of x, am I integrating it or am I taking the derivative of it? I'm going to take the derivative of it. So I'm going to first try the one that is going to eventually either disappear or make my integration a lot easier. Okay? So if I picked, we can look at it. If I picked my f of x to be cosine of x, I'm going to have to take the derivative of that, which isn't that bad. But then I would be picking x to be my g prime of x. And then you're going to have to take the antiderivative of that, and so you'll have x squared over 2, which makes things not any easier by any means.
So you're always gonna pick an f and a g prime, not an f and a g.
Right, exactly. Exactly. That's the formula.
Okay.
You have to pick your f and g over when you get to the bottom part.
We won't have to pick it over because the integral that we're left with is just sine of x dx.
If it was something more complicated.
If it was something more complicated, it's always possible that you'll have to do integration by parts again, or maybe you'll use substitution at the end, or a little algebra to get your answer, and we'll look at another one in just a second. But this one, the integration became really simple. I know the antiderivative of sine of x is negative cosine of x, so I didn't have to do any u sub or anything like that.
On the first one, the third line, why did you add subtract cosine x?
Because our original function that we were trying to integrate was x cosine of x, so I just solved it. Because over here we were deriving the formula for integration by parts. And so I just solved for it, and it gave me the x sine of x plus cosine of x that we would have gotten by just using the formula. Okay, and this is actually the way this problem is done in the notes. Good?
I have a question. So anytime if you derive it that way, you just take the function and take the derivative of it first and then move it.
Right. See, and we didn't use the same exact function. Because remember, it's supposed to be made up of some function and then the derivative of some function. Right? So I just took the antiderivative of that function. And so now that gave me f and g. So now I have f and g.
Okay.
Yeah. And then here's my f and g prime and my g. Does that make sense? Yeah. Any other questions on this one? That make it a little easier? I just confused the crap out of everybody. A little bit better? Alright. Okay. You want to see one more? Yeah? Yeah, okay. so I will do one where we're gonna have to do integration by parts twice, just so you can see an example of that. Alright, so we have the integral of x squared e to the x dx. So what do you think we should choose to be our f of x? X squared, okay? Because I'm going to have to take the derivative of that, and eventually, if I keep taking the derivative of it, what happens to it? It goes away, or it just turns into a constant, which is really easy to integrate. So I'm going to let f of x be x squared, and so my f prime of x is what? 2x dx, or just 2x. And so then my g prime of x is e to the x dx. And so g of x is just what? E to the x. Alright, so plugging into my formula, we get f times g, so x squared e to the x, minus the integral of what?
2x.
2x e to the x dx. Very good. So it's my f prime g now. Okay, so 2 is just a constant, so I'm just going to pull it out. So I get x squared e to the x minus 2 times the integral of x e to the x. Alright, so one way that you know you're doing it correctly is if your integral comes out easier each time you do it. If we came up with some weird funky thing that we weren't able to integrate, we would know possibly we did something wrong. So again, I have this integral x e to the x. But I can't just right off the bat integrate it. So what do you think we should choose for f of x now? X, because if I take the derivative one more time, what happens to it? It's going to just turn into 1. Alright, so we still have the x squared e to the x on the end, minus 2 times the integral x e to the x dx. Alright, so we're going to let f of x be our x, so f prime of x is just what? Dx. So g prime of x e to the x dx. And so g of x is just e to the x. Alright, so pretty much the same thing all over again. We don't want to forget our x squared e to the x out front, minus 2 times the formula all over again. So I have my f of x times g of x, so x times e to the x, minus the integral of what? Just e to the x, because we're going to do g of x times our f prime of x now. Or f prime of x was just 1 dx. We get e to the x dx. Which now I have e to the x, and what is the integral of e to the x? E to the x. So it eventually filtered out to a really easy integral. Okay. So I have x squared e to the x minus 2 times x e to the x minus e to the x plus some constant. We can go through and distribute 2, factor some stuff out, do a little algebra to make it prettier. Alright.
You're using that formula up there?
Mm-hmm.
and you started on the right hand side, just the F of X, G of X.
Right, exactly.
Where is that, where on here is the equal to the other side? Is that the lowest, on your side over here?
On where?
Like the, where is the, integral of F of X, G prime of X?
On this one right here,
Yes.
this is it. This is the integral of f prime of x, g of x. And this is our f of x, g of x.
What about the other side though?
Okay, so on this side,
Oh, that's the other side, under
well, what do you mean the other side?
of there. Like, see how it's F of X, G prime of X?
Right, that's our original function. So over here, this is the integral of x squared e to the x dx. That's just our original
Oh, okay.
function.
Oh, okay.
Okay, that's what we started with. Does that make sense now?
So after you plug them into the formula, then you just simplify or what?
From the second time we did it?
Mhm.
Okay, yeah. After we plugged it back in, the only integration we had left to do was just the integral of e to the x, which is just e to the x. So the next two lines after that, it was just simplification. I distributed out the -2, factored out an e to the x. Good? Better? A little bit? And now it's better. Sorry.
I have a question.
Okay, what's up?
So say it's actually some random number, and say you want to use that for F of X, you have to do it that many times to get it. And when you go down to so like in this instance, you have to do it 45 times.
Yeah. But we won't ever give you one of those on the test. Okay. Alright. Any other questions?
Okay, on that part when you got like, okay, it's an x squared e to the x, okay, is that what you e to the power of x? You got e to the x.
Oh, this one right here?
Okay, and then you got -2, then you got brackets, and then you got another minus. For some reason.
Right, okay. Because this part right here, we did the formula one time. We did integration by parts, right? But inside that, we still had an integral that I couldn't integrate. We had to do an integration by parts again. So I took the x squared e to the x, it's right here, minus 2 times this integral. Well, whenever we did integration by parts again, we had to plug it back into the formula. So my new f of x, f prime of x, g prime of x, g of x, plugging in the formula, this was my f of x times my g of x, and then minus the integral of, what is this? F prime of x, g of x. Which my f prime of x was just the dx. Okay, so that's why I enclosed the whole thing, because we had to do integration by parts again. And the whole thing was multiplied times 2. Does that make sense? Okay. Any other questions? Good. Anybody have anything they want to show today? A few of y'all? Alright, I know, hang on, I'm sorry, Seth. I know I'm supposed to be doing this, but do you think it'd be okay if people put stuff up, or do you want to go and try?
Absolutely, just make sure we do them in order, and by priority, you use down the list.
Okay.
Absolutely.
Alright, so I did that one. Alright, does anybody have 222 part 2? Alright, you'll have to forgive me on names. I'll try to do this as quickly as possible. Alright, Scorpio. Hang on, wait just a second. What's your name?
AJ.
AJ. What's your last name?
Garza.
Garza. Okay, you only had one. Who else had it?
Joe.
What's your last name?
Son.
You only have one. Who else? Jesse, I think you've done a few. And so have you, Scorpio. Alright, y'all both are kind of in tied. Do either one of you have another one you could show?
Knife fight.
Yeah, I know. Flip 4? Any, many, money, mo? What do we do with that? You don't have another one you can show? No. Joe, you? No. Alright. You're gonna hate me forever. I don't know.
You thought it was cool.
Alright. Okay, the only person I remember is Joe. Are you Joe? I'm sorry. That was the name I remember. Okay. Alright, 222-3. Scorpio, Lauren. What's your name? Last name? What is it? Jesse, I know you have a few. I think Juan, you have a few. You only have one? Oh, you're right. Do you have another one you could do besides that one?
0.4.
You have 0.4? Alright. You want to put up 0.3? Jesse, you get 0.4. What else we got?
Today I'm Brandy, I can circulate the ether plan.
Alright. Anybody have 222-5? You got it. Jesse, you don't have 222-5?
I think I was working on it.
Yeah, why you raise it?